Good morning, everyone. Thank you all so much for coming out this morning. Welcome to Princeton. Welcome to the workshop, which is the first of the Center for Information Technology Policy's major campus events here at Princeton. My name is David Robinson, and I'm the Associate Director of the Center. I am very excited about what we're about to do today. Ed and I this morning had a chance to have breakfast with some of you who had arrived last night, and already I think the cognitive substantive sparks were flying over the eggs and coffee. So I know that it's going to be an exciting session. Just a couple of quick things. First of all, this is our first event of this kind, so we're kind of winging it. If you have feedback for us as things go along about things we might adjust or to note, then please let me know or let Laura know, who's outside, who's sort of handling all of the logistics here. It also falls to me to let you know about the facilities. They're down the hall, but the really important ones, of course, are wireless. And what you're looking for there is PU Visitor, which is a wireless network which should be open to anyone's laptop who wants to use it. So with that, I would like to introduce our host for this workshop, Princeton's Dean of Engineering of the School of Engineering and Applied Sciences, Vince Poor. Vince?
Thank you, David. Thank you, David. Good morning. Let me also welcome you to Princeton and to the School of Engineering. You know, Princeton has an informal motto which goes something like this: Princeton in the nation's service and in the service of all nations. This was coined by some combination of Woodrow Wilson and Harold Shapiro, who's both were former presidents of Princeton. And basically the way we interpret this here is that Princeton should be involved in the societal good. And the way we look at that goal in the engineering school is that we should be involved in the public debate about technology and society. And of course, almost no technology, or perhaps no technology, is more important in that debate than information technology, or what David calls digital technology. First of all, because it's so pervasive, but also because it's evolving so rapidly that society has a very hard time in keeping up with developments in society. So we believe that it's important for technologists to be involved in this debate, mainly because they understand what the technology can do, they understand the limitations of the technology, and also because they have a sense of where the technology can go and what can happen in the future. So at Princeton, we've responded to this sort of mission, if you will, by forming the Center for Information Technology Policy, which is now about 2 years old, maybe slightly older, and Ed Felten, who you're going to hear from in a minute, is the founding director. The center is set up within the engineering school, but it has heavy ties to the other parts of campus. Here we're an engineering school in a very fine liberal arts university, and the center takes advantage of that position. So in particular, we have close partnership with the Woodrow Wilson School, which is our policy school here at Princeton. Ed has a joint appointment with the Woodrow Wilson School, but also ties with the other social sciences, the humanities, and so forth. The center, as I said, is only a couple years old. It's still relatively small. Ed's the founding director. David is our first associate director, and he's been here only a few months, maybe 6 months, I guess, at this point. So it's a fledgling center, but it's already doing important work, and we look forward to a great deal of more important work in the future. In particular, the goal of the center is really to provide research, or to do research that informs the public debate on how information technology should affect society and how society should react to that, to those effects. The center now is sort of a virtual center. We're scattered around, but we are building a building that will house the center. If you go at lunchtime, if you look across the way from this building, the Friends Center, you'll see a new building going up. And that building is a building that will house the Center for Information Technology Policy. It's strategically located midway between the engineering school and the Woodrow Wilson School. It's right on the edge of the social science neighborhood of campus, so symbolically and physically it's a bridge between technology and society, if you will. It's also, the center is, of course, takes resources, and together with resources from the engineering school and the generosity of Microsoft, for which we're very grateful, the center has been able to get started and do things like run this workshop. It's also part of our capital campaign, which was only launched a couple months ago. So if there are any philanthropists in the audience, I'll be happy to talk to you later. Anyway, welcome again. I hope you have a productive day, and let me turn the podium over to Ed. Thank you.
Thanks, Vince. As Vince and David both said, we're excited to get started here. This is the first workshop that the center has run, and we're so happy to see all of you here despite the scary weather forecasts. So let's get started. Looking at the registration list for this workshop, we saw a really interesting mix of people from different backgrounds, people with backgrounds in technology, in law, in public policy. We saw librarians, we saw members of the press, we saw students in a number of different departments from here and elsewhere, as well as quite a few representatives of industry. So this being a very diverse group, I was asked to give a tutorial talk to sort of talk about what it is we're here to discuss, computing in the cloud. This is a topic that makes some people sort of raise their eyebrows and ask, what is that again? So I want to talk a little bit about what computing in the cloud is, give a little bit of history and a little bit of sort of light technical background. All right. You see different definitions, actually, for computing in the cloud. John Markoff on the New York Times blog said it means moving computing and data away from the desktop and the portable PC and simply displaying the results of computing that takes place in a centralized location and is then transmitted via the internet on the user's screen. In other words, we're moving all of the computing, all of the function to some central data center, and the user is just displaying it. In our workshop announcement, we said the trend toward online services that run in a web browser and store users' information in a provider's data center. So we have computation in the browser, storage in the data center. Wikipedia says a computing paradigm shift where computing is moved away from personal computers to a cloud of computers. Now not to a data center, but to some amorphous cloud. And if you've been to many technology talks at all, you know that the universal symbol for the internet on a PowerPoint slide is a cloud. MIT Technology Review says the idea of relying on web-based applications and storing data in the cloud. Now the data is not in the data center, it's in a cloud. And Eric Schmidt, the CEO of Google, who probably arguably has the most to say about what's happening, says it starts with the premise that the data services and architecture should be on servers. Now the services and architecture are on servers. Okay, so you see different definitions. The only thing that I think people agree on is that it's about location. Computing and data are not in the places they used to be in, and that is supposed to a trend that's supposed to have significant implications. So why? Right? That's one of the first questions before us. Why does it matter where this stuff happens? In particular, if I'm an ordinary user, why does it matter to me why a bunch of geeky stuff that I don't even know about and don't care that much about happens inside software in my computer that I didn't design or on someone else's computer? Why should I care? Well, location turns out to be critical in actually determining the direction of things for a simple reason. First, that possession of something in the computer world implies control. If data is on my computer, I ultimately control when it gets deleted. I have some ability to move it around and copy it and operate on it. If a computation happens on my computer instead of yours, I have the ability to stop it. I have the ability up to a point to reprogram it, and so on. Even more so than in the physical world, in the computer world, possession implies control. And so where something happens has an important implications for who controls it. And of course, control over what happens in the world of computing implies power. If you can control what's going to happen, if you can control how people access information, you have some degree of power. And so the computing in the cloud is not only a technical trend, but it also has profound implications for who controls what happens in the online world. All right. In order to illustrate why this shift has happened, why it's happening now, and so on, I want to talk a little bit about the history of computing with an eye to this question of location. How has the location where stuff happens changed over time? Because one version of this history that you sometimes hear is the idea that there's a pendulum of fashion that swings back and forth between distributed solutions where everything happens on the desktop and central solutions where everything happens in a data center somewhere. And in this version of history, the pendulum swings back and forth just as hemlines go up and down and ties get wider and narrower. There's not necessarily any good reason for it. It's just that people get unhappy with the way things have been and they decide to try something else. And you do see what looks maybe superficially like a pendulum swinging back and forth. You may remember if you were if you were following technology 10 years ago, the burst of excitement over thin client systems. The idea that rather than having PCs on our desktops, we were just going to have computers that were more like smart terminals. All of the action was going to happen downstairs in the basement, in the machine room, or in some data center somewhere, which really didn't pan out. That went out of fashion. For a long time, for about a decade, we talked about doing things on PCs in a decentralized way, and now we're moving back to this idea of computing in the cloud. Nonetheless, I think this story about fashion doesn't quite work because it doesn't really explain. It doesn't really, first of all, explain what's happening, and second, it doesn't take into account the forces that actually caused this apparent pendulum swing. And so I want to go through sort of the history of the evolution of computing, and with an eye to this question of location, and to think about how all of this has been driven essentially by the economics of how computers are built and deployed. Okay. So in the beginning, there was the mainframe. Here's a color picture of a mainframe, which is a little bit rare. You had these big central computing systems. They were incredibly heavy. They were slow. They didn't do all that much, and if you wanted to compute, you had to go to them. They cost a fortune, so you couldn't have one of your own unless you were a very, very unusual person. This was inherently a centralized function just because it was so expensive, so big, and so heavy. So we started with centralization because there was no economic alternative. Then we came to the exciting development next, where you didn't have to go to the machine room. You could get one of these, a terminal, and you could be down the hall, maybe even on a different floor of the building from the computer, and still access it. And so we came to time sharing. The time sharing model was lots of people sharing the same big computer, but things still happening in the data center. This lets you share the resource, this expensive resource, more widely, but still things happen in the data center because it's just too expensive to give each person their own computer in all but the most extreme kinds of situations. So initially we had centralization for economic reasons. Then Moore's Law continuing to operate as it does, driving the cost of computing down drastically, we got to the point maybe around 1980 or the early 1980s, late 70s maybe, where personal computing came to be a practical idea. You started to see the first personal computers, and a few offices, a few homes started to have computers. And you started to get this degree of decentralization just because it was cheap enough to make a computer and deliver it to a home. If you were an engineer at the time, maybe you had this. This is a Sun 3 workstation. It's the same basic idea. It's still a computer that you got to have on your desk, but still somewhat expensive, but at least cheap enough that a few people could have them. So we had this move to decentralization just in order to reduce cost. Now, we could do things in a centralized way or a decentralized way, and the trade-offs were essentially this. If we wanted to do things in a centralized way, that gave the advantage of low cost. First, there were economies of scale in building computing systems, so you could build a big one for less than n times the cost of n little ones. And second, you could timeshare, meaning that if not everybody was using the computer at the same time, you only needed the computer to serve the people who were actually active at a time. If only a quarter of your users were active, you could save a factor of 4 by having a central shared system. Also, on the positive side, for a centralized system, you had expert management. You had well-trained experts in white lab coats who were operating the machine, and they perhaps would do a better job of management than you as an end user would. Certainly, you as an end user, even if you could manage the system, didn't want to. So having centralized experts managing was a good thing. On the other hand, in the distributed world, if you had your own computer, you had the opportunity to have a richer user interface. The terminals were relatively dumb. If all the computing happens far from you as a user, it would require a fair amount of bandwidth to communicate between the place where the computing was happening and you. So you could have a richer user interface if the computing was happening right there on your desktop. Also, you had autonomy. There was no person in a white lab coat telling you what you could or couldn't do. Management could send you a memo saying, please do X, but whether you actually did it was up to you. And so user autonomy was valuable to you. If you were a user, maybe more things could happen in that world. And so this was essentially the trade-off that we faced. You could do things in a centralized way. You could do things in a distributed way. The next development was the rise of what's called client-server computing. Client-server computing, the idea is you're going to have now computers in both places. You have a server that sits in the data center. You have clients which might sit on your desktop. Both are full-fledged real computers. And they interact. The client does things. It sends a request to the server. The server sends some kind of response back. So the client is telling the server what to do, and maybe some functions are put on the server, and some functions are put on the client. This is an idea that became popular in the 1980s and 1990s. So now we see for the first time a split between client and server computing. All right, so now we could put things on the server, we could put things on the client, or we could do this client-server thing where we did something like this. That is, we took what would have been a program that went in one place, and we cut it in half. We put half of it over here on the client, we put the other half over here on the server, and we arranged for each of these halves to not have their guts spill out when we cut it in half, and we arranged for the two sides to communicate back and forth to coordinate their activities. This is inherently a more complicated thing to arrange than computing in either place. You have two programs going on. They can get out of sync. One of them can fail without the other one failing. Their communications can get out of sync. And this whole process of cutting the program in half, arranging the communications, and so on, made everything more complicated. And so client-server computing was sometimes used, but didn't become widely popular for the masses. Then in the early 90s, we had the birth of the web browser. This is one of the early versions of Netscape. And you had the web model in which which is a client-server model in a sense, but you've moved almost all the intelligence to the server. You have here in a service provider's data center, you have a bunch of computers that act as servers. You have the browser that runs on the user's personal computer. And the browser in those days was really just displaying text, and the server was doing almost all of the work. So if you wanted to interact with this thing, you would have to click something on this page. Maybe you'd type something and then click a button. The stuff you typed or the button that you clicked would get transmitted to the server. The server would think about it, and it would send you back a new page to display. So this was really consumer technology starting to take baby steps down this path to client-server computing. Over time, browsers became more sophisticated, and as personal computers got more capable, as browsers became much more sophisticated pieces of software, they started to incorporate the ability to actually function more like platforms, to run software code. So you could actually run a program that ran inside the browser. And over time, programmers figured out how to take this facility, the browser, which was originally designed to display text, and talk to a server by saying, okay, here's what the user did, now show me the next page. And programmers eventually figured out how to morph this into something closer to client-server computing. So now you had something like this, This is Google Maps, which is one of the early examples of early popular examples of this kind of functionality. This is showing you how to get from the Nassau Inn to here. But in any case, this, although it's displayed inside a browser, in its innards actually is a computer program. This thing is actually a computer program. It gets information from the server about where the streets are and how they connect to each other and so on. But the actual thinking about what to display and where to draw this blue line and what to happen and what to do if the user takes the mouse and drags and so on, all of that is done here in the browser. So the browser, little by little, morphed from a text display and input mechanism into something that could really run something closer to full-fledged programs. And this happened little by little. And I think it was sort of a surprise to a lot of people to wake up and see the browser actually was functioning like this. Now, there's an interesting aside here, which is 10 years ago when the government brought its antitrust lawsuit against Microsoft. The government's, the Department of Justice's economic theory, the theory that they brought for how Microsoft might be harming consumers by their behavior, had to do with something much like this. The government said that the browser is threatening, is looking like it might be about to turn into a programming environment that might become a rival to Windows, and that Microsoft, the government said, was acting improperly to try to stamp that out. Now, what the government predicted in that case didn't happen at the time. Whether it didn't happen because it wasn't going to happen or whether it didn't happen because Microsoft stamped it out, you can debate over lunch. But in any case, it didn't happen at the time. And it's only now, about a decade later, that that very thing seems to be happening in spades. All right. Now, there's a cost to doing this. The technology is maybe even a little bit more complicated than the client-server computing I showed you before. Here, in this case, you have some software that's running in this case, Google's data center, which actually looks much more high-tech than that. You have some software that's running over here in the browser. And underneath, it's really this kind of client-server setup. You have some software that Google engineers wrote that runs here. You have some software that Google engineers wrote that runs here inside the browser. And they talk to each other by sending messages back and forth. So you have all the complexities of client-server computing. You also have the complexities of trying to shoehorn this into the browser as a setting. So if we take this apart a little bit more and look what's happening inside, we could see sort of what happens inside some of these cloud applications. All right. So first of all, you have these two programs that are running. Over on the server side, usually you have some sort of data store which is separate from this server. There's some big database where information is being stored. In the case of something like Google Maps, this data store will have in it not only all the information about the streets and how they match up, all the satellite photos and all that stuff that the service can show you, but also information about the users, what their accounts are, who the users are, what stuff you've searched for lately, and so on, as well as all the street view pictures that people have come to discuss more recently. So you have the data store down here. Data may land in here. The cost of data storage, of course, is going down, 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 meaning that a service provider who stores this stuff has an incentive to just keep it around. At least they don't have much of an incentive to clear it out in order to save the cost of storage. So stuff tends to build up in these data stores as a side effect of doing computing this way. All right. You also have a really bewildering array of technologies that gets used here. Unless you've actually built one of these web apps, even say as something like a class project, it's hard to appreciate how complicated the setup actually is that you use to make this stuff work. But let me give you an example. Just by talking about all the different computer languages that are used in this setup. So there's a language called SQL, which is used for the server, which is generally what's used for the server to talk to the data store. This is a language that's used to talk, that's used specifically to do operations on databases. So this is one kind of computer language that's commonly used. There's a language called PHP, which is used often to write the code that runs in this server. Sometimes other kinds of computer languages are used, but anyway, not SQL. So even here you have two different computer languages going on. Over on the client side, there's something called JavaScript, which is often used, yet another programming language, which is used to write the software code that is running inside the browser. So now you have this program which you cut in half into two pieces, only the two pieces are actually written in different programming languages. That's kind of a pain in the neck. You have something up here called HTML, which is used to describe the the imagery, the graphics that are displayed, and the text and so on that's just actually displayed in the browser window. And then you have a technology called XML, yet another text-based computer language, which is often used to transport stuff back and forth. So all this stuff is going on, all of these different languages are getting used, and the whole thing is frankly kind of Rube Goldbergish. It's surprisingly difficult to do. You might think that this is like sitting down and writing an ordinary computer program, but it's really not. You have to sort of wrestle all of these things. You're constantly translating the same information back and forth. So the user types something over here, which gets read into the JavaScript program and translated into XML and sent across here, and then PHP operates on it. And PHP writes a little SQL program that includes this data that came from the user through JavaScript through XML and becomes part of the SQL command that gets sent down here. This leads to all kinds of security problems. It leads to all kinds of practical problems getting things to work. Now, all of this technology coming along in the cloud has allowed not only existing applications like the lousy old map applications to get replaced by the more modern interactive maps, and things like email to be and video sharing, for example, to be done this way. It's also allowed new kinds of intermediaries to arise. One of the new intermediaries that's arisen because of this is eBay. eBay, of course, is a kind of cloud service where buyers and sellers are brought together. There's a big back-end data store that stores all of the information about who's buying what, who's selling what, who the users are, what their reputations are, all the transactions that need to be cleared, and so on and so on. And of course, all this is presented through a web browser. Another example is Facebook. Here's my Facebook page. But Facebook is another example of these new intermediaries. It's a kind of intermediary. It's a kind of service that you really would have been hard-pressed to figure out how to do unless you had this kind of technology. Unless you have computing in the cloud. Everybody's trying to read my page, aren't you? Unless you have this kind of computing in the cloud, unless you can store all of this stuff in the data center and assemble all of this junk from, my list of friends down here and all these people that I supposedly compared using the Compare Friends application. When really, it was just an errant mouse click. This wonderful we avatar picture of me and all this other stuff. All of this is getting assembled on the back end and dealt out to my browser. And the fact that we can all do this, the fact that we can, that Facebook is able to make connections between different users is all because of the cloud implementation strategy it uses. And of course, go one more step down that road and you get something like virtual worlds. Here's a picture from Second Life, but there are lots of other examples of sort of immersive spaces that people step into. Again, this is a kind of cloud application, although not implemented in a web browser. It's the same kind of structure where you have a back-end data center that has a lot of servers in it storing lots of information and coordinating the activities, letting what users see be evident to other users. Okay. So all of this has come along. We've also seen the growth of tools and infrastructure. This is actually one of the important trends right now. I talked about how so much of this technology is complicated and Rube Goldbergish, how difficult it is to make a lot of these things work. Also, if you want to go into this kind of business, you don't necessarily want to set up a big data center. So there's been a growth of tools and infrastructure. That is, services that are designed to make it easy to make one of these sites, to run them without having any physical computers that you own, and to deploy them quickly. One example of a sort of rapid deployment of an interesting site was the Iowa Democratic Party site. This was live on Iowa caucus night, and you could go there, and it would show you real-time feeds of the vote share, and you could click by county and all this other stuff and get the data. And this would refresh every 30 seconds. Very nice. It was built by somebody working for the Democratic Party or the Iowa Democratic Party, and and the guts of it were using facilities that were rented from Amazon. So this is an example of how you can put something up quickly and adapt to an increase in load by using these sorts of tools. The Republican Party didn't do this, and the Iowa Republican site was completely unusable on caucus night. Despite trying for about 45 minutes, I never did once get to see any vote counts. All right. So these tools are making it easier. They're lowering the cost of entry into providing cloud applications. And we're seeing more and more applications getting presented in this way. When we build a website for something even like the Center for Information Technology Policy, we think, what can we do to make it more cloudish? All right, so we're back to this issue of location. I've talked now a little bit more about the technology, and what we see in this technical picture is lots of stuff being stored in data centers. We're seeing the programming, we're seeing the computation that implements a service being split between places. And as I said before, possession implies control. Where it happens implies who controls it, one of the prime rules of computer security, and control implies power. All right. I want to talk now a little bit about the implications of this kind of model for policy questions, which is what we're all here to discuss. And I'm not going to steal the thunder from any of our panels. I'm going to, in fact, defer all of the interesting and hard questions to them. But I want to sort of give you some idea of the space that we're going to be discussing. Okay. So first, possession of data. Many cloud services involve big data centers where some company or some service is storing tons of data about the users. And the questions of possession of data, where data which may once have been in a previous generation of technology been stored on your own computer, is now stored somewhere else. Your email is stored maybe on some service. Your home movies are stored maybe on some service. Your finances maybe are stored in some service. All of that raises implications, the first of which is privacy. So you have the obvious privacy issue. The data is held by a third party. You now don't have physical control over it. You might worry about what this third party is going to do. Will they have your best interests at heart? Are the promises they're making to you now about what they're going to do going to hold true in the future? You may worry as well about privacy with respect to the legal system. If someone shows up with a subpoena at this third party site, is the third party, will you be as well prepared to resist that subpoena as you would be if you had the data yourself and the subpoena came to you? The answer is probably not. If government wants to engage in surveillance of some of this data to get it for law enforcement purposes or anti-terrorism purposes or whatever, how does that change? The fact that the data is held by a third party has interesting legal implications, which I will allow the lawyers on our first panel to talk about. Security is another important thing that changes when we move to the cloud. We have this more complicated setup. We've taken this program, we've ripped it in half. We have this communication. All of this makes it harder to secure. But there's more going on than that. The service provider has some interest in making sure that certain data stays secret. They have some interest in protecting the integrity of certain data. They want to make sure if this service is a bank, for example, or a financial service, they want to make sure that information about account status is not modified, even though information is flowing across here, maybe information is flowing back. So the server has certain guarantees that it wants to maintain. The user over here has certain guarantees they want to maintain. I may not trust this service provider all the way to do just anything with my information. So you have information flowing back and forth. Some information is going to be replicated, stored in both places. And both sides, the client and the server, have interests in protecting the confidentiality and integrity of this data. How are you going to do that? And how are you going to do that in this Rube Goldberg-ish setup that I talked about before? There's all kinds of issues having to do with portability and preservation of data. You might like to see that your data is preserved, or in some cases you might like to see that it's not preserved. In any case, you want to have control over data that's about you or data that pertains to your activities. If someone else is holding the data, that control may be more difficult to put into practice. Preservation as well, portability as well. If you're using one service and that service builds up data about you, you as a customer will want to be able to move that information off to a rival service if you decide to change. The service, on the other hand, may have a business model that's built around the idea that you can't just willy-nilly take your data somewhere else. There are interesting issues also about possession of computation. A slightly strange term, but what I mean here is the fact that computation happens in one place versus another. Because it's not just control over data that comes from possession of the data, but control over how computation is done comes from where the computation is done. The fact that computation about, say, your checking account or your email has moved to a service provider's network means that service provider has more practical, technical power over how that computation happens. And so that leads to the possibility of a struggle for power based on a struggle for where the computation is going to happen. One of the big issues here has to do with market power. If you have an intermediary who has a large customer base, and they're holding data for a lot of customers, and it becomes difficult for customers to move their service from one place to another, there's a concern that that provider will have market power that they'll then be able to push around their customers, and that the effect might be, A, bad for their customers and perhaps bad for the public as well. So our panelists can debate how big a problem is that. We can also observe that a lot of these companies behave with the idea that they know that their customers are concerned about market power. This is one reason, for example, why many of these services try to set themselves up as communities. Right? We're a community. Your members, your participants, we value you. It's a way of saying we're not going to be the bully who's going to push you around. Don't be evil. Again, this is the idea that that Google has followed. This idea of working really hard to project an image and try to convince their users that they have a level of moral qualms that perhaps they suggest their competitors might not, as a way of diffusing this concern about market power. All right. But if you believe that something more than that needs to be done about this market power problem, you have some choices. You could go in for ex post regulation. That is, once the data is stored, once the information is stored, once the provider has the level of power they do, you could use regulation to prevent them from misbehaving in certain ways. Or you could try to rely on ex ante agreements. That is, try to get the provider to make promises up front about what they will and won't do, promises that are designed to protect the customer. These ex ante agreements probably... This, of course, it's the moment before the customer comes to the service provider, when the customer has the most opportunity to extract an agreement like this. And so some people will argue that ex ante agreements driven by the market may be enough to protect people. We'll let our panelists debate that. Civics in the cloud. We have a very interesting panel tomorrow morning about this question, about how government can be made visible to citizens and connected with citizens in a different way because of cloud services. And we'll see some interesting examples of that. As well as government in the cloud, the question of how government agencies, executive branch agencies in particular that act in a regulatory capacity, can open their processes more to citizens and change the way that they interact with citizens, to reduce the sort of headache of interacting with that we often have in interacting with government, and to make the processes more transparent. All of this very important. The role of new intermediaries, the way that new intermediaries have changed the game, and the interesting issues for public policy that these intermediaries bring up, also very interesting questions. eBay, Facebook, virtual worlds, and so on. So we have many interesting questions to discuss. We'll end with a panel about what's next, which I'm also eagerly looking forward to, and we have many interesting things to discuss, so I'm eager to get to work. Thank you.